Hello, in this video we're going to talk about a problem on placing letters of x on a plane. Show that we cannot place an uncountable number of letters of x on a given plane in such a way that no two x's have a point in common. So what that means is that we can place an x here and an x here and an x maybe here and an x here, etc. But whatever we do, as long as these x's do not overlap, there would have to be a countably many of these letters of x. And just something to kind of avoid making obvious arguments is that these letters of x do not have any thickness. So these are segments. So this is one segment from A to B and one segment from C to B. So that's what we mean by a letter of x. Because if you make the letters of x to have thickness, then the problem becomes significantly simpler. And the second question that it's asking us to prove is that prove that this can be done when the letter X is replaced by the letter O. Let's first look at the second part of the problem. Is there a way we can create an uncountably many letters of O on the plane that they do not intersect? So can we place an uncountably many letters of O on the plane without intersecting? Well, this is not very difficult. So one way of doing that would be to place O's to have the same center. So assuming that the O's are ellipses, this is how you can do that. So let's assume that every O has an equation of this form: x squared over a squared plus y squared over b squared equals some constant. And this constant would be what is changing. Now you can decide what is the ratio of the major to minor axis. These letters of O do not intersect. Why? Because if you have a point on x squared over a squared plus y squared over b squared equals c, and you change your c, you do not get any intersection, because as c changes, there are no intersections on these letters of O. So this is an uncountably many letters of O because the set of positive real numbers is uncountable. So this is an uncountably many letters of O that is placed on a plane without intersecting. Okay, now let's get to the business about letters of X, which is more complicated. So we want to show that that cannot be done. We cannot place we cannot place uncountably many letters of X on a plane. So let's do that. Okay, so what does it mean? What are we trying to show? We are trying to show that if we place letters X on a plane, then they will be countable. So there will be countably many of them in that set. So what are the countable sets that we know? Let's list the countable sets that we know. We know that the set of all positive integers is countable. The set of all integers is countable. We know the set of rationals is countable. We also know that if we take two countable sets, their Cartesian product is countable. So things like this, Q cross Q is countable, etc. These are all countable. So the strategy is for every letter of X, associate some point that these points are countably many and they do not overlap. So what does that mean? So here's what I'm going to do. I'm going to create four regions. So I'm going to connect these. I get four triangles. Let's say I'm going to go clockwise, and I'm going to pick a point here, A, in the first region, a point B in the second region, a point C in the third, and a point D in the fourth region, in a way that all of these points are going to give us a countable set. So what are the countable sets that we know? These are at least the ones that we can think of. Now, this one seems to be an appropriate one. In these four regions, we're going to choose four different points, A, B, C, D, but we're going to choose them from a countable set. So we're going to choose four different rational points in these triangles. Because rational points on the plane are dense, we can find points that are rational inside every triangle. And then we're going to associate to every x. So to every x, we associate a an ordered 4 points. So this is in Q basically 8, which is countable. So to every x, we associate this. And we know that Q8 is countable. Okay, so what do we need to show in order to show that the number of x's is countable? What we need to do is that we need to show no two x's are associated with the same element of Q8. So let's assume you have two x's, one x here and A, B, C, D associated to this x, and some other x also has the same 4 points in the same order. Now, what is the contradiction? Well, what we can say is that if we look at these two, if we connect these two, well, these two would have to intersect both of the the segments on the axis. So AB connects both of them, and BC also connects both of the other two. So intuitively, that's clear that there should be a contradiction here, because these four would have to intersect um, the opposite sides. So how do we kind of make that more rigorous? So let's say the sides of the first one are S1 and S2, those two segments. So what can we say? We can say that A and B are on opposite sides of S2. And we also know that C and D are on opposite sides of S2 as well. So we know that. So what does it mean? It means there's an intersection point here and an intersection point here. Let's call this point maybe E and this point F. Okay, so I know that there's a point E on X on AB. So E is on AB and F is on CD. And these 2 points E and F are on one of the letters X. So we know that. So in a similar fashion, we can find 2 points, maybe G and H. So G and H are on the other X. So that means because G and H are on BC and AD, GH and EF intersect. So what does that tell us? It means the two letters intersect. And that's exactly what we wanted to avoid, which means we cannot place an uncountable many letters of X on the plane that they do not overlap. I will see you in the next video.